Okay, so on your warm-up, you guys, let's look at the cosine side of the function first, and then we're going to do some notes, and we'll come back to the sine. But on this, it says the domain, and domain is all the possible x values. So what are the possible x values in degrees? It's infinite, right? So it's really all real numbers. Oh, sorry about that. That looks really bad. Oh, let me change that. There we go. Hold on. Okay, so it's supposed to be a big, one of those double R's for all real numbers. Okay? You can do that too. And in radians, it's also in all real numbers, except it's in radians, okay? So I'm just going to do this. All right, so the range, we already said the domain is the x values. What is the range values? The y, right? Yep, so it's y values are always going to be between. -1 equals y. Yep. And that is the same for radians.
So is radians basically everything the same except for when the zeros and then
Right. Wow. And when you talk about max and minimum, where they are. Okay. So on this cosine, where are the x values? What are they? Where are the zeros?
-3 pi over 2.
So it's right here.
Well, yeah, they're at
right here.
-270, 90, 270, 450, and 630.
Right. So that's what you would list. So -270, -90, 90, 270, ... You get the idea? Okay? And if you're doing this in radians, it would be -3 pi over 2. Okay? -pi over 2. Pi over 2. ... Okay? Where is it maximum on here? Yeah. Right here is a maximum. Right here is a maximum. Yep. So this would be -360, 0, 360, and so on. Where, what is it in radians? -2 pi. Good. Now I want to know where are my minimums. Yep, at 180, at -180, and 540.
I just don't get why it says on that example sine. Is it saying like when sine theta equals 1?
Yeah. So this is when cosine theta equals 1.
I mean, yeah, but yeah, sure.
What is the yellow?
But like if we were looking at a sine
wave.
why?
Okay, so that's when the maximum is of sine, or this in this case we're looking at cosine. The maximum of cosine is when it equals 1, right? So when you go to look at your sine function, the reason why it says this right here is sine is at its maximum when it equals 1, and it's at these points right here. So let's go quickly and look at that.
Oh.
Okay, I'm going to pull that up right now. Okay, here's our here's our sine wave right here. Where is it maximum on here? Yeah, so at 90, the sine wave is at 90, 450, and -270, right? For the sine wave. So if I go back to our other one here, 90, 450, 810. And then if I look at the max, what is it in radians? It's pi over 2, 5 pi over 2. So this will be pi over 2, 5 pi over 2. Yeah, no, I didn't go that far.
Oh, okay.
Yeah. So looking at the sine wave here, when are the zeros on the sine wave? Yep, 360, 180, 0, negative 1 to 80. Wave, the zeros are here at negative 180, 0, 180, 360. So if you write that down on this, I already forgot it. Yeah, 0, negative 180, 180. .360, and so on. You can change those to radians right here. Okay, now the range on the sine wave. What's our, is there a max or a min that the sine wave can go?
1, 2.
Yeah, it's 1 to 1 again on this one, right? Okay, so that's what we're going to write down on this side of it. It's going to be negative 1 less than or equal to y less than or equal to 1. Same with this. And the domain? Yep. Okay, so basically, can you guys tell me what are the differences between the sine wave and the cosine wave?
They're offset.
They're just offset. Yep.
Wait, okay, what is the yellow stuff say?
This is pi over 2. 5 pi over 2. Negative 180.
And is that the same? Oh no.
No, they're not. They're different on the sine wave. Okay? So basically, if you take your notes and fill this in, right here, this is square root of 2 over 2, square root of 3 over 2, 1, square root of 2 over 2, and 1/2, and 0. Okay, and then it kind of repeats again on the bottom, but they're all negative. It's the exact same as this. These two lines are the exact same, except these are negative. Okay? The bottom line on this is 0.707, 0.866, 1, 0.866, 0.5, and 0. And then it should repeat again down here, except it's negative. All right, so now if you move on down, if you were to graph this, you should have gotten something like this in your graph. Okay? Okay, further on, here's the rest of your notes for that page. The function that maps each real number, theta, to the y-coordinate of the image, 1, 0. Okay? How big is that circle that we're making a picture of? It's got a radius of 1, the unit circle. That's why we're starting off at 1, 0. So under the rotation of theta, it is called the sine function. From the unit circle, you can tell that sine theta is positive between 0 and 180, and negative between 180 and 360. The maximum value is 1 when theta equals 90 degrees. And the minimum value is negative 1 when theta equals 270. Okay? So this is just one cycle of the sine function. Okay? Now, if you look over to the right here, it says a graph of the sine function between 0 and 360 is shown. To make it easier to locate the zeros, maximum and minima, the scale on the horizontal axis is in multiples of pi over 2 and 90 degrees.
I thought you might, that's right.
That's why we started talking about it.
This is one cycle of the graph of the sine function, which repeats itself every 2 pi. the graph can be easily extended, so I can continue this on if I wanted to, like this, or I could go this way. Of course, that's not to scale, but you get the picture. Okay? All right. Down below is the cosine function, which is basically the same thing, except it's basically it's moved over by how much? What's the difference between this and this? By how much? 90 degrees or pi over 2. Okay, so it's a phase shift of 90 degrees or pi over 2. That's the only difference between them. So remember that the image of 1/0 under the rotation of magnitude theta is cosine theta sine theta. The function that maps the real number theta to the first coordinate of the image is called the cosine function. Okay, so remember that the first coordinate is the x, the second one is the y. Okay, and I'm not going to fill out the chart below because that's exactly what we did during the warm-up.